Hi there, my name is Saeid. I'm with Prep 101. In this primer, we will talk about intermediate value theorem. This is a theorem that is a result of continuity, and it's one of the topics that is discussed in the first midterm of Math 186 at U of T. Okay, let's get started.
Okay, intermediate value theorem is one of those interesting theorems that is the result of continuity. So let me explain that on a graph. Assume that you have a nice and continuous function. So by continuous, we mean there is no jump, there is no hole, there is no discontinuity, there's no vertical asymptote on an interval. So let's say this is A and this is B, and our function is nice and continuous on that interval. So between A to B. And right here at A, I have f of A, so that's some value f of A, and I have B, and then I have f of B. So again, the function is continuous, doesn't have to be positive, it's continuous between A and B, and the values at A and B are f of A and f of B. So intermediate value theorem says if you draw a horizontal line, between f of A and f of B, in other words, for any value between f of A and f of B, let me call that k, there is some value on the function, there is a corresponding value on the function that we call it c. So that's kind of obvious when you look at the graph, and you might wonder, okay, what is the application of this for something such obvious? So once again, intermediate value theorem says if you have a nice and continuous function between A and B, and the values at A and B are f of A and f of B, for any value k between these two y values, there is some values c between A and B. Because if you draw any horizontal line, it will intersect the graph at least once. I mean, it could be more than one c, but there's at least one c value between A and B. Okay, usually this theorem, first year calculus courses, is used to find whether the function has a root. So imagine if I give you the same graph, but this time A and B will give you values with two different signs. For example, the value at A is a negative value, so here, and the value at B is a positive value. So f of b is positive, f of b is negative. That means f of a and f of b have opposite signs. And this is the continuous graph that I have. So according to intermediate value theorem, and the function is continuous, remember, it should definitely cross the x-axis at least once. So it can go from the first to second point this way, or it can go this way, right? Obviously, it cannot go this way. I mean, in any case, it will intersect the x-axis. So that means it will intersect the x-axis at least once. And remember, when a function crosses the x-axis, the function has a root. So as long as f of a times f of b is negative, and it could be the opposite, it could be the other way, f of a is positive, f of b is negative. As long as when you multiply them you get a negative sign, that means they have opposite signs, then the function at least has one root between a and b. So that's a nice property. In some cases we're not able to solve for roots of a function algebraically. This method would be really, really handy. So let me give you examples. Show that f of x equals x to the 7 has a root on negative 1 to 1. So what I need to do, of course, if you know the graph, you are able to show that. But in many cases, either the function is so complicated or we don't know the graph of the function. So if I can show that f of negative 1 and f of positive 1 have opposite signs, then that means, according to intermediate value theorem, there is a root between negative 1 to 1. I mean, you obviously know that the root is 0 in this case, but we're just testing intermediate value theorem, or IVT. F of negative 1 is negative 1 to the power of 7. That's just negative 1. 1 to the 7, that's just 1. So you see that f of negative 1 times f of positive 1 is a negative number. So by intermediate value theorem, the function has a root on -1 and 1. Now, let's do a question that is a bit more complicated than this. So I have to show that this function has at least one root. Well, sometimes the interval is not given to you, so you have to come up with it with your own interval. And this sometimes requires a bit of trial and error. So what I want to do is to find two numbers that when I substitute in an f, I will get opposite signs. So f of x is equal to x to the 5 plus 10x plus 3. Think about two numbers. You might want to start substituting some numbers. For example, I can substitute 0. That gives me 0 plus 3, which is 3. I can substitute 1. That's going to be 1 plus 10 plus 3. So that would be 14. So you see that this doesn't work because you're basically getting opposite signs for both of them. But what if I try -1, for example? If I try -1, I would get -1 to the 5, which is -1. -1 times 10, that's -10 plus 3. So in this case, I did get a negative number. So basically, I got -8. And you see that you can either use these two numbers, or you can use this number and this number. Again, that will be the interval that is different. So, let me just use these two numbers. So since f of 0 times f of -1, so if I multiply those two values, I get a negative value. And according to intermediate value theorem, because I got two opposite signs, the function f of x has at least one root on -1 and 0. So the function has a root, or at least one root here, and that means overall the function has at least one root. So this is one application of intermediate value theorem, which is commonly the case in first year calculus.
I hope that you found this useful. If so, check out more foundations of first year calculus in the playlist. Also, make sure to join our Facebook Study Hub for this course. You can find the link in the description box below. Finally, I hope to see you at my prep session. I will show you how to solve midterm and exam problems, and how to do that with confidence, and how to ace your midterm and exam. Remember that many prep sessions for midterms are free. Visit prep101.com for more details. Thank you for watching.